everyone, welcome back. Let me begin by saying thank you to each and every one of you for all the subscription, views and the likes. We have 17 subscribers now. That is 17 people who love science and brain so much that they are willing to listen to me talking their brains off. So thank you very much. For those of you who are stumbling upon this video now, I'm Dr. Ilavarasi Joseph and I'm making educational videos in neurosciences. Today we will be talking about what is our current understanding on the effects of COVID-19 on our brains. But before we begin, just in case if I forget to mention it at the end of the video, like I did in my last video, I appreciate all your feedbacks, comments and thoughts. See, I'm an academic researcher by training and I thrive on conversations and picking the brain of others. Please don't be a stranger, share your thoughts, and if you have any questions, throw it in the comment section. I'm looking forward to reading all of them. That's being done, let's talk about COVID-19 and the brain. The most well-known neurological symptom of COVID-19 was the loss of smell. Loss of smell has a fancy name, anosmia. Almost all of us had experienced that at one point or the other when we catch severe cold and flu. We lose our sense of smell and cannot eat anything because the sense of smell and taste are linked together. And you know, cold and flu is caused by the virus, and not surprisingly, coronavirus is part of the gang. But unlike cold and flu, where we get our sense of smell and taste almost immediately back, in the case of COVID-19, some of the patients did not regain their sense of smell even when they recovered from the disease. In a study that traced 2,428 patients, 40% of the patients reported that it took them almost 6 months to regain their sense of smell completely. 2% of the patients did not see any improvement at all. So what is happening in the olfactory lobe in the case of COVID-19? How is this viral infection different from all the other viral infections that has caused anosmia in us for years? In this video, we will look into the answers to these questions. And in order to understand those answers, let's take a look at the structure of the olfactory lobe first. If you know me, my favorite thing to say is that in biology, in order to understand the function, one has to look at the structure first, as structure determines the function. So, it's time for biology lesson. We all have a pair of olfactory bulbs located in the forebrain. By the way, the Institute of Human Anatomy has a cool video of the olfactory bulb and olfactory nerve, and I will give that link in the description below, so please do check it out. Below the olfactory bulb is the bony structure called cribriform plate, and below the cribriform plate is the olfactory epithelium. The olfactory sensory neurons and the support cells called sustentacular cells that wrap the neurons very tightly, and the Bowman glands are all present in the olfactory epithelium. When we smell something, the odorants travel towards the olfactory epithelium and gets dissolved in the mucus. The odorant molecules are then transported to the dendrites of the sensory neuron, which then communicates that information through its bundle of axons called olfactory nerve cilia to the second set of neurons in the olfactory bulb called the mitral cells. The axons of the mitral cells then relay that information to the various parts of the brain. The cells in the olfactory epithelium can be harmed by the toxic chemicals that we inhale every day, so they are replaced every 60 days. The stem cells in the olfactory epithelium differentiate into the new olfactory neurons, and as long as there are axons to guide them to make connections with the mitral cells in the olfactory bulb, our sense of smell will be functioning. Now that we know the structure of the olfactory bulb, let's take a look at the first question. In order to understand what kind of damages are happening to the olfactory system, a group of scientists did CT scans and MRI studies on patients who had lost their sense of smell due to COVID-19. They found that the shape of the olfactory bulb itself has changed in those patients. Normally, the olfactory bulb is oval or inverted J-shaped. In those patients, they were rectangular shaped, and in some cases, the size of the olfactory bulb has considerably been reduced. In MRI, regions where there are lesions always show up as very bright and are called T2 hyperintensities. These lesions are due to demyelination and loss of axons. In the patients with the COVID-19 related anosmia, such spots of high intensity were frequently observed. There were also spots of low signal intensity observed in the olfactory bulb of those patients, indicating regions of microhemorrhages occurring inside the olfactory bulb. Another thing that was observed in those patients was that the olfactory nerve cilia that is the bundle of axons that are going from the epithelium to the olfactory bulb, was abnormally thickened and clumped together compared to the patients without anosmia. Taken together, there seems to be loss of axons, demyelination, microhemorrhages, as well as changes in the architecture of the olfactory nerve fibers in the patients that had COVID-19 related anosmia. Other than viral infections, anosmia can also happen due to blunt force trauma, like in the case of professional fighters, and due to aging, chronic sinusitis, and diseases such as Parkinson's. Most of these cases can be treated with steroids if the underlying cause is inflammation. Just a side note, it is always a good idea to include foods such as berries, avocados, nuts, and fish every day in your diet, as these antioxidant-rich foods can act as anti-inflammatory agents. If you have already guessed it, I'm from India, and turmeric is an everyday ingredient in my kitchen as it has rich anti-inflammatory properties. Even if the damage to the neuron is physical due to trauma, remember the cells are getting replenished every 60 days. So as long as all the axons are not completely destroyed, it is possible to regain the sense of smell once the new axons grow and make the connections. In the case of damage to the axons, like the demyelination seen in the MRI, it is still possible to strengthen the neurons and regain the sense of smell through olfactory training. It is a safe, self-driven training that anyone can do. One basically uses the 4 primary orders: flowery, fruity, aromatic, and resinous, to retrain the nose by recalling all the past memories and experiences, and thereby bringing the neurons and the connections to life. You take a drop of the rose scent or a rose flower, put it under your nose and inhale it for 15 to 20 seconds, and while doing it, you intentionally try to think about how the rose smell, how do they look, when was the last time you get the rose flowers, or any other memories that is related to the smell of rose. If you recall, the relationship between the olfactory system and the cortex is very deep. You see, the projections not only go to the olfactory cortex, it also goes to the hippocampus, amygdala, and to the reticular formation. That's the principle behind olfactory training, combining all those emotions and the visual images and tying it to this particular scent, and thereby training the nose to smell. Once the flowery smell is done, the process is then repeated with the 3 other remaining scents. The exercise can be repeated for 2 to 3 times for a while, and it is possible to get a slow but steady improvement in the sense of smell. The reason why this can happen is time for biology lesson again. If you look at the structure of the neuron, in order for the neurons to function, they have to be part of a network. The part of the neuron that carries messages in a neuronal network is your axon, and it carries messages in the form of electricity, and the structure called myelin sheath is the one that allows it to carry electricity over long distances without weakening. Now when you smell a rose, the neuron for the smell is going to get stimulated, and the axon will carry that information to the mitral cells in the olfactory bulb, and from there it will be carried on to the rest of the brain. If you smell often, just like when you are doing the olfactory training, more myelin will be deposited onto that particular axon, which is the way the brain marks that the particular neural pathway is important and therefore needs to be strengthened. This is pretty much what happens when we learn to play a new instrument or learn a new language, and I will discuss it more when we talk about how we learn and how we form memories. When it comes to anosmia, regaining the sense of smell is possible, and it might take 3 months or 6 months or even up to a year, as it depends on the type and the level of damage that has been caused by the COVID-19. If you liked this video and found it to be useful, please share it with your family and friends. Subscribe to this channel and let me know in the comments what you think and what was your experience. I will discuss the neuropsychiatric effects of COVID-19 in the next video. Till then, take care.